problem number 4. Write a function, uncorrupt, removed columns equals removed columns A. Okay, I'm going to start there. So function, call your variables whatever you want. I'm going to call them U and R. Remove columns, make sure it's named correctly, A. Save my file. It's a function, same name. Okay, which takes in an array A, so A is an array, removes all the columns of A if the column contains at least one value that is equal to -9999. The function return output uncorrupt, the matrix A with the columns removed. So uncorrupt is my matrix with them removed, and output removed columns with the indices of the removed columns. So which columns were removed. Okay, I'm gonna first figure out which columns to remove. There are several ways to do this. I'm going to do it with a for loop right now. So I'm going to identify the number of columns in A. So size of A, comma 2, number of columns. I'm going to say for I equals 1 to C. So iterate over the columns of A. And I'm going to check if a column contains an invalid value, contains a corrupted value. So if sum A all rows column I, so if the column contains a number that's equal to -999, I have to sum it because if needs a single number. If needs a single number, so I have to sum them. I can't just say if A is equal to -999, the whole column, because that's going to give me 4 numbers or 3 numbers or 7 numbers, however many rows it has. So I'm just going to sum it together. If that sum is greater than 0, that means it contains an invalid value, a corrupted row. And then R is just going to be where I add that row to my matrix. So R is going to start as an empty vector. I'm going to say R is my original R plus my I value. So this is one way to add the column index to R. So I'm iterating over all of the columns. I'm saying if the column equals -999, sum all of those logicals. If it's greater than 0, that means it's corrupted. And I'm going to just keep track of that value. So R equals Ri. So whatever my original R value was, or whatever my original R array was, plus my I. I'm going to leave the semicolon off just because I want to see if it's working. Once I do that, once I figure out which columns to remove, then I can just remove them. I can say A, all rows, columns R equals empty. I can just say delete them. And then here U would be my A. So here's my output. So I'm going to say U is my output with the rows deleted. I could do this first and then delete them from U, or I can do it last. Okay, so this one, it's a little bit harder to use rand in order to come up with this example. So I'm just going to use the example that's written out. So 7, 4, 8, 1, 8, 7, -9999, 1, 8, 2, 3, 9. So A looks like that. In theory, my U should be this column removed, and my R should be 3. So I'm going to go ahead and test my function. And we can see that U contains this column, and this column, and R contains 3. So this was printed out inside my function. So I'm going to go ahead and come up with an example where A has another value, just to make sure it works for more than one. So now A looks like this. So I'm going to remove my columns. So R is first 3, and then it's 3 and then 4. U contains this column, and R is 3 and 4. So my function is working the way I expect it to. There's more than one way to do this, specifically more than one way to figure out which rows or which columns I'm going to remove. So let me go ahead and show you how to do that a different way. So we could just say that the locations that are corrupted would be A equals to negative 9999. If I do this, evaluate selection, it's going to give me a 1 here and a 1 here. So same idea that I did here. I'm just checking to see which values in A are equal to negative 999. I can sum this array too. So sum, so essentially my columns, column lokes, I can sum lokes. If I just do this, notice it gives me my sum along my columns. So it sums up this to 0, sums up this one to 0, this one to 1, this one to 1. If you sum up an entire vector, it gives you one number. If you sum up an array, then it's just the sum of each column. So now I have a 1 in row 3 and row 4. So now I can use that for what's called logical indexing. So I know my columns are equal to 1 to 4. I know I have 4 columns. It's whatever 1 to size of A, comma 2. So that means my R would be wherever call lokes equals 1. So these are my column indices, 1, 2, 3, 4. I only want the 3 and the 4. So I'm checking to see where is calls. I want the values in calls where calls lokes equals 1. So here's calls lokes equals 1. And it grabs just the 3 and the 4. So this is another way that we can make use of our conditionals in order to figure out what R is going to be and which columns to remove. So that's our first step, figure out which columns to remove, and then I can go ahead and delete those columns by saying A colon R, so which columns in this vector to make empty.